Hi, today we are going to talk about the module of working on the boat. But before that, I want to go deeper about the center of mass. We have already known the definition of the center of mass. Now, we will write the equation by multiplying the m total to the other end of the equation. It gives an interesting view because I can take the derivative of both sides. Assuming m total is constant and the masses of each piece is also constant, then I can have an interesting relationship. Remember that the derivative of xcm is vcm. Thus, I got a very similar relationship, but in mass times velocity. Mass times velocity is a very particular physical quantity called momentum. The total momentum of the system is equal to the individual momentum of each pieces. Of course, you can take the derivative again to get m total times acm. Based on these two equations, we can calculate the velocity of the center of mass and the acceleration of center of mass. We can also know that for the entire system, the acceleration can be zero. If it is zero, then the individual pieces also can be accelerated, same as the velocity. Also, forces applies. For example, I have two objects, one tugs the other based on Newton's third law. The other object must have a reaction force that is same magnitude but in opposite direction. I can say for the entire system, there is no external force. The inside pull and push are cancelled out. Let's sum up. In an isolated system, which means that there's no external force acting on the system, that is, m total times acm is equal to 0. Thus, we can have m total times vcm is constant value. If m total times vcm equals to 0, then we can have m total times xcm is a constant value. Now, let's apply it to the working on the boat module. Let's see the question. A 80-kilogram person that is at the end of the boat. If the person moves 1 meter to the right relative to the water, how far back did the boat move? Generally, it is an isolated system because there's very little friction between the boat and the water. That is very little force in the horizontal direction. In the vertical direction, actually the external force exists because the gravity and buoyant force are here. We hopefully the boat won't sink, so we can treat it as the gravity and buoyant force are cancelled out. There's no acceleration in the vertical direction, so we can work as an isolated system. Some students may say that there is a friction between the person and the boat, but it's just like what I mentioned earlier, that it's an action and reaction forces. They are equal magnitude in the opposite direction and acting on two objects. And for the whole system, boat and the person, the force actually is cancelled out. So it actually is an internal force, not external force. So yes, it is an isolated system, so I can apply this reasoning. Whatever the changing person is, the boat is doing an opposite change. If the whole thing starts from rest, whatever the force the person is on the boat by walking, that's it. The boat is doing an opposite change and the center of mass will now shift. So I can write the equation mass of one piece times the distance it covers equals to masses of the other pieces times the distance it moves. Let's assume 1 is the person and number 2 is the boat. We know the 80-kilogram person goes 1 meter and the 100-kilogram goes a distance we don't know. Here's a small tips. Here I'm omitting signs here. I purely do in scalar. Of course, the opposite direction has positive and negative signs, but it always brings errors. So now we just leave all the things positive. Just bear in mind, I know that the boat, of course, going to the left and the person going to the right. Just bear in mind, that's all. Then we got the result that the distance the boat went is 0.8 meters. Of course, it points to the left, but it won't shown in the calculation. Does it make sense? We know the boat has greater mass than the person, then the boat must have less distance to keep the center of mass at the spot, so it makes sense. Here's another example. I have to do a minor changes, which are highlighted in green. The moves is no longer relative to the water, but relative to the boat. The difference is the person do not go 1 meter right relative to the water. He actually go a smaller distance, less than 1 meter. Then the boat goes some distance back. But here is a problem that we don't know both the distance the persons go and the distance the boat go relative to water, so we have two unknown here. But luckily we know that the sum of the two unknowns is 1 meter. It's still an isolated system, so we solve the problem in the same way that we have the equation m1 d1 equals to m2 d2. That's the number 1 is the person, number 2 is the boat. Also another information, d1 plus d2 equals to 1 meter. We combine these two equations. Both m1 and m2 are known. m1 is 80 kilogram and m2 is 100 kilogram. Then we can solve the equation. Got d2 equals to 0.44 meter. Okay, that's all for today. If you have any question, please join the QQ group. I'm here to answer the question for you.